roots here. So I'll write root 1, root 4, root 9, root 16, root 25, and root 36. All of these square roots can be written as whole numbers. So the square root of 1 is 1, root 4 is 2, root 9 is 3, root 16 is 4, root 25 is 5, and root 36 is 6. But what about all the square roots in between these numbers? So root 2, root 3, root 5, root 6, root 7, root 8, root 10, root 11. All of the other square roots we call surds. These are numbers, these are square roots that cannot be written as whole numbers. So for example, root 2 cannot be written as a whole number. It's 1.414 and so on. It goes on, so if I try to write it as a decimal, I could be writing numbers forever. It never ends, and there's no pattern to the numbers. We call that an irrational number. So a surd is an irrational number. It's a square root that we can't write as a whole number. Okay, now we're going to look at the rules of multiplying and dividing square roots. I haven't actually picked surds here. I've picked square roots that we can write as whole numbers, and that will be useful for showing you that these rules work. So the first one, I've got root 4 times root 9, and root 4 times root 9 is the square root of 4 times 9. 4 times 9 is 36. So I'm going to say root 4 times root 9 is equal to root 36. And I can show you that works because root 4 is 2, root 9 is 3, and root 36 is 6. So 2 times 3 equals 6. And I'll write this as a rule. So root A times root B equals the square root of A times B. The second one, I can also divide square roots. So root 36 divided by root 9 is equal to the square root of 36 over 9, and 36 divided by 9 is 4. And I'm going to show you this works again. So root 36 is 6, root 9 is 3, and root 4 is 2. So 6 divided by 3 equals 2. That works. And the rule is root A over root B is the same as the square root of A divided by B. There isn't a rule for adding or taking away surds. So you cannot simplify surds by adding them or taking them away from each other. And I will show you this doesn't work. So I'll show you that root 4 plus root 9 is not equal to 4 plus 9, which is 13. And that's because root 4 is 2, root 9 is 3, and 2 plus 3, which is 5, isn't root 13. Root 13 is not 5. So this is not a rule. There's not a rule for adding surds. And root 9 times root 9, or root 9 squared. So square rooting and squaring are the opposite of each other. So if I've got a square root and I square it, I end up with what I started with. So root 9 times root 9 is equal to 9. And I can show you that's true by doing 3. Root 9 is 3, and 3 times 3 makes 9. Or we could also use the first rule So root 9 times root 9 is equal to square root 9 times 9, square root 81, and square root 81 is 9. So the rule is, if I've got root a and I multiply it by root a, that's equal to a. Okay, so these are my rules for multiplying and dividing surds. Okay, so let's look at multiplying some surds. So for the first one here, I've got root 2 times root 5. So 2 times 5 is 10. So root 2 times root 5 is root 10. This time I've got 5 root 3. So 5 times root 3 times 2 times root 7. So when there's nothing there, it means times. So if I could rewrite this, I'll rewrite it here. 5 times root 3 times 2 times root 7. So what I can do is I can multiply the 2 and the 5. So the two normal numbers, multiply them together. So 5 times 2 is 10. And I can multiply my two roots together. 3 times 7 is 21. So root 3 times root 7 is root 21. Here I've got root 15 divided by root 5. 15 divided by 5 is 3. So root 15 divided by root 5 is root 3. And I've got 6 root 14 divided by 2 root 7. I can divide my ordinary numbers. 6 divided by 2 is 3. And root 14, so 14 divided by 7 is 2. So root 14 divided by root 7 is root 2. Okay, so 4 questions for you to try. Pause the video, give them a go, and press play when you're ready for the answers. Okay, so the first one, 3 times 11 is 33. So root 3 times root 11 is root 33. For the second one, I'm going to multiply the ordinary numbers. So 4 3s are 12. Then I'm going to multiply my roots. So 5 times 2 is 10. So root 5 times root 2 is root 10. 30 divided by 6 is 5. So root 30 divided by root 6 is root 5. And again, the last one, divide the ordinary numbers. So 8 divided by 2, that's 4. And root 12, so 12 divided by 3 is 4. So root 12 divided by root 3 is root 4. Now with the last one, I've got 4 root 4. Square root 4, so this square root 4 here, can actually be simplified because square root 4 is 2. So this is equal to 4 times 2, which is 4 times 2, 8. Okay, now we're going to look at simplifying surds. So a surd is simplified when we've got the smallest possible square root number, the smallest possible surd. So we can simplify surds by taking out square numbers. For example, root 18 is the first question, and 18 has got a square number that's a factor, and that's 9. So I can change root 18 into root 9 times root 2. 9 times 2 is 18, so root 2 times root 9 is root 18. And with the square number, I've got root 9. Root 9 can be written as 3. So that means root 18 can be written as 3 times root 2, or 3 root 2. For the second one, I've got 2 times root 8, 2 root 8s. I can simplify root 8 because it's got a square number again as a factor. So 8 is 4 times 2. So I can change 2 root 8 into 2 times root 4 times root 2. Root 4 is 2. So that's 2 times 2 times root 2. 2 times 2 is 4. So it's 4 root 2. Okay, root 98. It's a bit harder. So what square number is a factor of root 98? So 98 is 2 49s. So root 98, I'm going to write as root 49 times root 2. So 2 49s make 98. So root 2 times root 49 is root 98. And root 49 is 7. So it's 7 root 2s. And finally, so I've got root 588. So this one is much harder, and I've put it here so I can show you a way of simplifying the most complicated surds. So what I can do is I can take 588 and break it down into its prime factors. So 588 I can say is 2 times, well, half of 588. Half of 500 is 250. Half of 88 is 44. So 250 plus 44 is 294. I can half 294 again. So it's 2. Half of 200 is 100. Half of 94 is 47. So 147. And then 147 is in the 3 times table. And it's 3 lots of 49. And 49 is 7 times 7. So I've broken 588 down into its prime factors. So 588 is 2 times 2 times 3 times 7 times 7. So root 588 is root 2 times root 2 times root 3 times root 7 times root 7. And root 2 times root 2 is 2. Root 2 squared is just 2. Root 7 squared is just 7. And I've got a root 3. So I've got 2 times 7 times root 3. 2 7s are 14. So I've got 14 root 3. And if I grab the calculator and type root 588 in, the calculator would simplify it for me, and I can check that I've done it correctly. So there are 4 questions for you to try here. Pause the video, give them a go, and press play when you're ready for the answers. Okay, so root 12. Root 12 has got a square number as a factor. It's got 4. So I can change root 12 into root 4 times root 3. And root 4 is 2. So I've got 2 root 3. Root 50 is 2 25s. So root 25 times root 2. Root 25 is 5. So I've got 5 root 2. 3 times root 45. Root 45 has got 9 as a factor. It's in the 9 times table. So I can say I've got 3 times root 9, and 9 times 5 makes 45. So root 9 times root 5 makes root 45. And root 9 is 3. So I've got 3 times 3 times root 5, which is 9 root 5. And finally, I've got root 450. So I might have to break it down. So let's break it down. So 450, if I say that's 10 times 45, and 10 is 2 5s, they're both prime. 45 is 5 times 9, 5's prime, and 9 is 3 times 3. So root 450 is equal to root 2 times root 3 times root 3 times root 5 times root 5. Root 3 times root 3 is 3. Root 5, so when I've got pairs, I'll match them up. So root 3 times root 3 is 3. Root 5 times root 5 is 5. And I've also got a root 2. 3 5s are 15. So I've got 15 root 2. And to finish up, we've got 6 questions. So pause the video, give them a go, and press play when you're ready to carry on. Okay, so question 1, we've got root 3 times root 7. 3 times 7 is 21. So root 3 times root 7 is root 21. Question 2, simplify root 200. So what square number is a factor of 200? So the biggest one is 100. So we can take 100 out. So root 200 is root 100 times root 2. And root 100 is 10. So we've got 10 root 2. Question 3. 6 root 3 times 2 root 2. So we can multiply the ordinary numbers. 6 times 2 is 12. And multiply the roots. 3 times 2 is 6. So root 3 times root 2 is root 6. Question 4. Simplify 3 root 72. So what is the biggest square number that's a factor of 72? That is 36. So I can change root 72 into root 36 times root 2. So 3 times root 36 times root 2. Root 36 is 6. And 3 times 6 is 18. So I've got 18 root 2. If I had picked a different square number, I would have had to simplify it again. So if I had picked 9 and done 3 times root 9 times root 8, I would have had 3 times 3 times root 8, which is 9 root 8. But root 8 simplifies again because I can change it to root 4 times root 2. So we've done 9 times root 4 times root 2, which is 9 times 2 times root 2, which is 18 root 2 again. So carrying on, question 5. So we're dividing. So 15 root 30 divide by 5 root 5. Divide the ordinary numbers. 15 divided by 5 is 3. Root 30 divided by root 5 is root 6. So 3 root 6. And finally, question 6. I've got 6 root 5 times 2 root 5. So 6 times 2 is 12. And root 5 times root 5, I could write root 25, but root 5 times root 5, or root 5 squared, is just 5. So that's 12 times 5, which is 60.